Yeah, plan yourself to come here on coming Monday. Okay, so from there it will be offline classes. I don't take online classes from there. Okay, thank you. Okay, coming to this, can you see my screen?
Yes, sir.
Yes, sir.
Thank you. Okay, in the last class, I was talking about subqueries and correlated subqueries. Okay, so there is one of the important intro question: nth maximum salary. Did I explain about the nth maximum salary?
No, sir.
No, sir.
Okay, fine. Now I'll do that. So, nth maximum salary. So here, nth maximum salary. Okay. Yeah. Okay. See here. This is a table. I have only two columns here, but only one table. But I'm showing as a two tables: employee A, employee B. Both are same tables, but showing as a two tables. Okay, with alias name. So here we have just two columns: employee number and a salary. So we can write a query to get a nth maximum salary. For example, if I want highest salary, I can get it. If I want second highest, third highest, fourth highest, I can get any okay highest salary, any least salary. So nth least salary, nth highest salary. Okay. So this is a very important interview question, and it can be done with correlated subqueries. So let's see here how this query is going to be executed. So this one, we have only one table. Physically, we have one table, but I'm showing that as a two tables here because EMPA, EMPB, two tables with a correlation name. Can you see that? So select star from EMPA. Both the columns are star. You can give star here, no problem. Okay, from EMPA, where n minus 1 equal to select count of distinct of b dot salary from EMPB, where a dot salary is less than b dot salary. Okay, select count of distinct of b dot salary from EMPB, where a dot salary is less than b dot salary. Let me explain about how this query is going to be executed. For example, if I want highest salary, okay, for example here, if I want highest salary where n is 1, if I want second highest salary where n is 2. So what is the n minus 1? If I want highest salary, what should I give here? 1 minus 1, what is that? A 0. Okay, so now, for example, I'm looking for a highest salary, which I need to give a 0. If I'm looking for a second highest salary, I need to give a 1. So let's see what's going to happen here. So now it's a correlated subquery because I have given my outer query column, outer table column in the inner query where condition. Can you see that? Where a dot salary is less than b dot salary. This is my outer table column and used in the where condition of the inner query. Okay. So let me show you out how this query is going to be executed. So it starts from outer table. For every row of the outer table, it goes to the inner query. Okay, it selects the value, and that is verified in the outer row again. So it starts from outer row. It's a very important. This is very important because you'll come to know how the query is executed internally. So now my outer table, because outer table column is used in the inner query where condition. Now the query execution not starts from a doesn't start from the inner query. It is going to start from the outer query. So it takes the first row of the outer table, then it goes to the inner query. So what is given here? Where A dot salary is less than B dot salary. Where A dot salary is less than B dot salary. What is the A dot salary here? 20,000. 20,000 is less than 20,000 is less than from the B table. How many records are there? 20,000 is less than 30,000. 20,000 is less than again a 30,000. 20,000 is less than 35,000. 20,000 is less than 40,000. Yes or no? How many records we received?
4.
4 records. But out of that, count, first of all, take the distinct of B dot salary. See here we have a 30,000, 30,000, 35,000 and 40,000. We got 4 records, but out of that there is a duplicate. Can you see that? 30,000 is duplicated. Yes or no?
Yes, sir.
Yes, sir.
So that means we should not take the 30,000 twice. So 30,000, 35,000, 40,000. How many records are there?
Got
3.
Only 3.
3
Only
records.
3 we got. Only 3 we got. After removing the duplicate, we got only 3. This one, and this one. So I'm looking for 0, but I got 3 here from the subquery. So my outer row will not be selected. This row is not going to be selected because I'm looking for a 0. I'm looking for a 0. That means highest salary. This is not a highest salary because I'm going from outer row. I'm taking outer row from the outer table and going into the inner query and calculating it. So I got 3 here, but I'm looking for 0. Then it go to the second row of the outer table. It takes 30,000. Then it will go to the inner query. So where 30,000 is less than 35,000 and 40,000. 30,000 is less than 35,000 and 40,000. So these two are distinct only. There is no duplicates here. So what is the count here?
2.
2. So now, one second. Sorry for that. So now I'm looking for 0, but I got a 2 here. So even this row is not going to be selected. This is not a highest salary. Then it will come to the third row. So 15,000. 15,000 is less than, okay, 20,000, 30,000, again a 30,000, 35,000 and 40,000. So 1, 2, 3, 4, 5. But out of that, there are duplicates. So we get only 4. Out of 5 records which are selected from the subquery, if you remove the duplicates with a distinct, we get only 4. So what is the count of that? We get 4. But I'm looking for 0. Even this 15,000 is not selected. Then it will go to 30,000 again, next row. It goes to the inner query. So 30,000 is less than 35 and 40. So we get 2, but I'm looking for 0. Then it will go to the next row. 35,000. 35,000 is less than 40,000. So what is the count here? 1, but I'm looking for 0. So 40,000, okay, is less than none of these records. There is no, okay, record selected in the subquery. Yes or no? 40,000 is less than. Is there any record? This 40,000 is less than.
No, sir.
Any record
Okay.
here? No.
No, sir.
So we get 0. That means this is the highest salary. So here we got a 20,000. Do you remember? 30, 30, 35, 40. So which is a 3. For 30,000, 20,000 we got 3. For 30,000 we got 2. For 15,000 we got 4. For 30,000 again we got 2. For 35,000 we got 1. For 40,000 we got 0. Okay. So now if you use a 0 here, we get the highest salary. If you use 1 here, we get the second highest salary. If you get 2 here, we get both of these, this record and this record. And if you give a 4 here, 3 here. Okay, we get this one, and we get 4 here, we get this one. Do you understand how this query is executed?
Yes, sir. Hello, sir. I have doubt.
Yes, go ahead, please.
Sir, if you use max salary from A or B, so
Hmm.
it is possible or what?
I'll tell you. I'll tell you. Get a max salary, select. Yeah, very good question. Now we'll get a lot of clarity. Select the max of salary from EMP. This is where you get a max salary. Can you get a max salaried employee details? Because aggregate function cannot be combined with the normal columns unless until you have a group by. Can you give a employee number, comma,
No,
max
sir. No,
salary?
sir. No, no.
No. So if you want to get a max salary employee details, you need to write a subquery. If you want to get a max salaried employee details, I should give a subquery like this, where salary, okay, equal to. So I should move this one to subquery. Star from EMP, where salary equal to select max of salary from EMP. So now I get a max salaried employee details. Yes or no?
Yes, sir.
Now, if I want a second maximum salaried employee details, okay, I'll show you here. Here, salary less than select max of salary from EMP. Now, this innermost query is going to be executed. We get a maximum salary. So the outer query here takes the rows other than the maximum salary, less than the maximum salary, where salary is less than the maximum salary. Apart from the maximum salary, we get other salaried employees. From there, I'm taking a maximum salary again. That is equal to, okay, the outer query. So now innermost query executed. First, it gives a maximum salary. Then apart from the maximum salary, we get other salaries. From there, I'm taking a maximum salary. That means the second highest salary. That is equal to salary. So my outer query gives a second highest salary details. If I want third highest, see here how difficult it is. I need to write a lot of queries like this. Now we get a, okay, third highest salary details, which is easier. If you want a 10th highest salary, do we write a 10 subqueries? Or do you go with a generic query like this? Which is easier?
General query.
Generic query, right? So we write a generalized query for nth maximum salary. If you want nth least salary, nth minimum salary, just reverse this condition. Instead of less than, you greater than. One of the important interview question. Yes. Do you understand?
Yes, sir.
Can I move to the next topic?
Yes, sir.
Yeah, here one more point. If you want a top three salaries, I want a 0, 1, and 2. Top three salaried employee details. Correct? In that case, 2 is a less than or equal to, or else you can write in the right side. That's better. You can write in the right side. That's far better, actually, more readable. So if this inner query returns a 0, 1, or 2, so the output of this is less than or equal to 2. The less than or equal to 2. Now we get a top 3 salaries. If you want a bottom 3 salaries, we need to give a reverse condition here. If it is 0, for example, top 3 salaries. If it is 0, if it is 1, if it is 2, this condition will be satisfied. If it is 3 less than or equal to 2, is it true?
No, sir.
So we get a top 3 salaries like this. Like this, we can use a top salaries or top 3 salaries, or a bottom 3 salaries, bottom least salary, or a last three least salaries, whatever it is. You can get a solution for any of these requirements. If you understand, then I'll move to the next topic.
Yes.
First of all, for normal subquery, these are normal subqueries. See here, subquery has no dependency on the outer query. Outer query is depending on a subquery value. Outer query is depending on a subquery value. So subquery can be executed independently. Okay. Subquery can be executed independently. Then the result is given to the outer query, then outer query executes. This is a normal subquery. But coming to the correlated subquery, outer query is depending on an inner query value. Inner query is also depending on an outer query value. So that's the reason my query execution cannot be executed from the subquery. It will start from the outer query. For every row of the outer table, the inner query is executed once again. Okay. Fine. Now, let me move on to the next topic, joins. Which is a joins. A very, very important joins. Okay. Before we go to the joins, I think we need to see about unions. Yeah. Unions. Okay. Not this, sorry for that. Yeah. Let's see here. I have two tables, business contacts, non-business contacts. Okay. So contact number, contact name. This is a business contacts and this is a non-business contacts. There are two different tables available, but similar columns. Column name need not be same. For example, here mobile number and a person name. Here contact number, contact name. I can have different column names, no problem at all. But these are two different tables. But similar data is stored in that. Similar columns are stored in that. Okay. So business contacts and non-business contacts. Coming to this, business contacts and non-business contacts, but I want to merge this data. I want to merge the data. I want to take all the contacts. I want to take all the contacts, both the business contacts and then non-business contacts. I want to get all the contacts. So for that, what I can do is I can write a select star, and also I can write a select star, and I can put them. I want to concatenate this data. I want to merge this data. So for that, what I write is a union. So select statement, no semicolon, no semicolon. If you give a semicolon, that's the end of the query. But here the semicolon comes in the end of the second query. So select statement on the first table, select statement on the second table, and I want to merge these two tables data. So that I want to use a union all. Union all. Union. So union is to combine the rows from two or more select statements. Union is to combine. Union is to combine. Okay, the rows from multiple select statements. Do you understand?
Yes, sir.
So I get a data like this. So if I use a select statement and select statement here, and in between union all, it's going to merge the data. This data is merged with this data. So I get records like this. But there are some common contacts are there. For example, this one is available here. So my business contact is also there in my non-business contact. Maybe personal contacts, whatever it is. So it's also there. And here, this record is also available here. Okay. Fine. Now, if you go for union all, it is going to combine the rows, but it's not going to eliminate the duplicates. It's not going to eliminate the duplicates. First of all, if you want to go for union or union all, you must have the same number of columns from both the select statements. Here, number of columns. Here, number of columns must be same. The column names need not be same. For example, contact ID. Okay. Contact name, or simply name. But here, person number, okay, mobile number, mobile holder name. I can give a different names, but names may be different. But the number of columns and should be same, and the data type and length should be same. Number of columns should be same. What I am selecting in the first query, what I am selecting in the second query, number of columns must be same, and the data type and length must be same. Do you understand the rule?
Yes.
Okay. But in case, for example, business contacts, we have a company name. But assume there is one more column name, company name. But we don't have that company name. We don't have a company name in the non-business contacts. So it doesn't work. You cannot give a different number of columns. In that case, what we can do to compensate it, we give a null.
Sir, I have a doubt.
Yeah, go ahead.
Sir, I have merged this data. So many row is like a same duplicate. So how to remove this?
Simple. If you remove this all, if you simply give union without all, that is going to eliminate the duplicates. No need to write a distinct. No need to write a distinct here. Union all automatically eliminates the duplicates. So union eliminates the duplicates. Union all combines all the rows, but union eliminates the duplicates. Do you understand?
Okay, sir.
Yeah, I'll come to that a little later, but let me show you. So what are the rules to code a union or union all? The number of columns in all the select statements which you are using a union or union all must be same. Okay, number of columns, and data type and lengths must be same. But in case if you have different column names, different column numbers, for example, Here I gave given 3 columns, but here I given only 2 columns. 2 columns. So you cannot combine these rows. It will fail. To overcome that, for example, that company name is not available here. In case if the company name is there, get the company name. If the company name is not there for a personal contacts, so give null. You understand? Or for those missing columns. For those missing columns. Because in the first query we have 3 columns, in the second query we have only 2 columns. But I want to combine these rows. In that case, I give a third column as a null. Do you understand?
Yes.
For all the rows that are selected from the second query, second select statement, it will be null in the third column. I hope you understand.
Yes, sir.
Okay. Okay, next one. If you go for a union, okay. So how many queries can be combined like this? How many queries can be combined like this? Is it only 2 select statements? No. We can combine as per the interview questions, it's a 15. But now it is changed to 225. 225 select statements can be combined. But normally we don't go like that. But the possibility is there. We can use a union all for a 225 queries. So what is the difference between a union and union all? Union eliminates the duplicate. See here. Here I given union. So those duplicate rows are eliminated here. Can you see that? How many rows are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 rows are selected in the first union all. But here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So
Sir,
these rows are eliminated.
hello.
Yes,
Sir,
please.
if you have same name but different contact number,
That's
so
what.
it
It's
will
not a
count
duplicate,
as,
right?
yeah,
I'll tell you.
please.
I'm coming to that. I'm coming to that. Here, the entire row is a duplicate or not. It's going to check like that. So is it a duplicate? The phone number is different. Name may be same. Name may be same, but phone number is different. Is it a duplicate record?
No.
That's
No,
why
sir.
it's not eliminated. Okay. Are you clear with this?
Yes, sir.
Coming to the other concept, intersect. There is one more concept called intersect. Here, intersect. That means common rows from both the tables. That means what are the common rows here? What are the common rows? This one and these two, right?
One
These
and
two,
two.
these two. So these are common rows. So intersect gives you common rows. Union combines, so union all combines all the rows. Union eliminates the duplicates but combine the rows. Intersect gives you common rows, but it eliminates the duplicates. It doesn't take a twice here. If you give intersect, this is and this is. So out of these two, only one set will be given. If you give intersect all, it will be giving a 4. These rows and these rows. So generally we don't use a intersect all. Intersect all. We don't give an intersect all. Even we don't use a union all. Generally we give a union. Because if there is a duplicate, why do we need the duplicate? We can generally eliminate the duplicates. You understand?
Yes, sir.
So here, intersect all. Intersect. Generally we go with the intersect. Intersect means only we get a common rows from both the select statements. Hope you understand the intersect concept.
Yes, sir.
So we have a few things here. Let me tell you. We have union, intersect, except. The three concepts are there. Union gives you, okay, it combines all the rows and eliminates the duplicates. Intersect gives you common rows. Except gives you, okay, the rows available here but not available there. For example, if I write a query like this, select contact number, contact name from business contacts, except select contact number, contact name from non-business contacts, except. So remove this company name. So if you give except, so what is the result? Except. So which are available here but not available here. Which are available here in the first table but not available in the second table. So this one and this one is already here. So I don't get these two records in the output, but I get this one and this one. These four records I get it in the output. So the records available in the first select statement but not available in the second select statement. That's called except. Do you understand? Guys, do you understand?
Yes, sir.
So I get a rows from the first query, but not available in the second query. Okay. So how many records we get if you use except here? Only 4.
4.
4.
But if you give second query first and first query next, you will get these 4 records. So except means available in the first set, but not available in the second set. Available in the first set, but not available in the second set. That's called except. Union intersect means which are available in the both the sets. Available here and there in both the sets. That's called a intersect. And this is except. And union combines the rows and eliminates the duplicates. Union all doesn't eliminate the duplicates. If you understand this, I'll move to the next topic.
Yes, sir.
Yes, sir. You can go to the next topic.
Yeah, we should know the rules. It's very, very important. If you are going for a union or an intersect or except whatever it is, you should have the same number of columns in all the queries. And in case if any of the query is not having the same number of columns, you need to compensate that with a null. If you have 3 columns in the first query and 2 columns in the second query, you cannot combine like this. You have to use a null keyword. Okay. So union all, intersect, except. So they ask you question, what is the difference between a union and union all? These questions are not asked, except and intersect they didn't ask, but most of the interviews asked about a difference between a union and union all. And they asked about the rules. Okay, if I have 3 columns in the first query and I have 2 columns in the second query, can I use it like this? No. We have to give a null as a third column in the second query. Okay. Then let's come back to join. Yeah, let me show here in the joins. And they asked, many interviewers asked about the difference between a union and join. Union and join. Okay, I'll show you here. See here, I want to get a customer names and also employee names. Customer names and employee names. I want to combine these rows. What is the concept? Is it a join or a union?
Union.
It's a union.
It's a join.
I want
Union.
combine the rows. Customer names as well as the employee names. I want to select like this. See, for example, take last name of employee, take a customer name. So select customer name from customers, union, select the last name from employees. So 91 customers are there and 10 employees are there. And there are no duplicates. There are no duplicates. So that's why I got a 101 rows. Do you understand? This is a union. I'm combining the rows. I'm combining the rows. So let's move on to join. Let's move on to join. See here. We have orders. In the orders, we have a customer ID, employee ID, order date, shipper ID. Order ID, customer ID, order date, and customer name. Where is the customer name? Where is the customer name here? In which table it is available?
Customers table.
Yes,
Customer table.
there in the customer table. Okay. Mostly we join the child table with its parent table. We have already seen that orders table is a child to 3 different parent tables. On a customer ID, the parent table is a customers table. On an employee ID, the parent table is an employee table, employees table. On a shipper ID, okay, the shippers table is a parent table. Mostly we join a child with a parent. Of course, it's not a rule. It's not a rule. We can join any table. If you have a common columns, we can join it. It need not be okay a child and parent, but mostly we join a child with a parent. So now I want a order ID, customer ID, and customer name. Okay, let's see. No problem. Product is sensitive. Order ID, customer ID, customer name. But there is a common name here. Customer ID is a common name in both the tables. Yes or no?
Yes, sir.
Yes.
So we need to qualify it either with a table name or with alias name. Yes or no?
Yes, sir.
So if you use a multiple tables in the from clause, that's called a join. If you use a multiple tables in the from clause, in earlier all examples we used only single table in a from clause, but here I'm using a multiple tables. I need a data from 2 different tables. I need a data from 2 different tables. I want data from the employees, orders table. I want data from the customers table. So I'm using a customers. Need not give it like this. Just for a better readability, I'm giving it like this. No need to give a braces like this. Remove it. Select the order ID, customer name. From which table we are taking order ID? Is it from orders table or customers table?
Orders table.
Yeah.
Orders table.
Orders
Orders
table.
table. And customer ID is a common name from both the tables. So now we need to qualify this. From which table you're taking from? Otherwise, you get it'll throw error. Okay. A dot. And from where we are taking the customer name?
B dot.
Customers table.
Need not
Customers
give
table.
a B dot. Need not give a B dot because it's not a duplicate name. If the common name is there in both the tables, then we have to qualify it. Otherwise, no need to qualify it. Order ID is available in the order table. Customer name is available only in the customer table. But customer ID is available in both the tables. So we need to differentiate it. Okay. Where this customer ID equal to this customer ID. You understand? Select order ID, customer name from orders, customers, where, okay, the customer ID in a orders table equal to the customer ID in a customers table. Do you understand this concept?
Yes.
So this is called a join. Now I am taking a columns from multiple tables. It's not like I'm not combining the rows from two different queries. Union is totally different. I'm combining the rows from two different select statements. But here I'm taking the columns from multiple tables and putting into a single query. So we're using a multiple tables in the from class. So let's see here how many records we get. How many orders are there? 196. So we get a 196 rows. For every row, we get the customer name. See here.
But you already told this.
Sorry?
You already told this in previous
Yes,
classes.
I understand, but I didn't say the rest of the concepts. So there are a lot of things in the. See, when I was explaining about the relations between the tables, I explained this concept. I know it. But I didn't say each and every point of the join. Now I'm going to explain it. Do you understand?
Yes, sir.
Okay, so that's the reason I am explaining this concept. Okay, once again in depth. So let me tell you this. So join means combining the columns from multiple tables. In the from class, we get multiple tables. In the where class, we use a join condition. So we got 196. But let's see. 91 multiplied by 91 multiplied by 196. What is the number here? 17836, correct? There are 91 customers and there is 196 orders. So, but if you do not give a where condition, it's meaningless. It's meaningless. So I want for this order, for this customer, I need a customer name from the customer table. That's what this where condition decides. If you do not give a where condition, let's see what is the result. What is the number? What is the number of records we received here?
17,836.
Yeah. So how did we get it? Number of rows from the first table multiplied by number of rows in the second table. See here, customer 90 is not a Nancy, right? Customer 90 is matched with every name of the customer table. 91 is repeated.
Meaningless data.
That means it's a Cartesian product. In the technical terminology, we say it's a Cartesian product. So every row of the customer orders table is matched with every row of a customer's table. Every row of the order table is matched with every row of the customer table. So that's why 196 rows are mapped with 91 rows of customer's table. Do you understand? This is one of the important interpretation. If you do not give a where condition in a joins, what happens? It gives a Cartesian product, which is a meaningless. Guys, all of you, do you understand this concept?
Yes.
So the where condition is very, very important. The join condition is very, very important. Okay. Can use a where condition on a different columns. Customer ID equal to customer name, which is meaningless. Correct or not? Where customer ID
Yes.
equal to customer name. Let's see. If you join with the incorrect column name, we don't get any record. No result, because this customer is not matched with any of the customer name. There's two different columns. So we generally join with a foreign key with a primary key. Foreign key with a primary key or unique key. Mostly we join the child table with its corresponding parent table. Do you understand? But that's
Yes,
not a
sir.
rule. But mostly we combine a child table with a parent table. We use a where condition on a foreign key equal to primary key. Foreign key of the child table equal to primary key of the parent table. We always use a equi join. We never give a non-equi join. Sorry for that. Not this. Again, it's meaningless. See here, 17836 minus 196. What is that?
1764.
Right. From the Cartesian product, what are the matching records available? It will leave that, and what are the non-matching records available? It will take that. Is it required actually? I want a customer name of that particular customer, but it will give us the customer name of all other customers other than this customer. Is it meaningful?
No.
No. Generally, we don't use a non-equi joins. We always use a equi joins. Non-equi join is a meaningless. Guys, do you understand?
Yes, sir.
Okay. So let me go to the left outer join, right outer join, and full outer joins. Okay. Now I can do this in my mainframe for better, because we have sufficient data here. Now I'm writing a query. Select employee number. Okay. Last name, work department, department name from EMP. Okay. Here we don't have a common name. We don't have a common name. Work department is a column in the child table. Department number is a column in the parent table. Or else I do it now. Select star from EMP. Okay, and select star from DEPT. I want to show you both the queries. First, let me execute both the queries. Two different queries. We got the employee details. Employee number, first name, middle initial, okay, and then last name, work department, phone number, hire date, then job, education level, sex, birth date, salary, bonus, commission. These are all the columns available. And we have a 42 rows available. And come to the department details. We have 5 columns and 14 rows. 14 rows. Before I show this, I want to update. I will update one of the employee work department. Let me show you that. I'm writing update query. Update EMP set work department equal to null, where employee number equal to 00010. So do you understand what I'm doing here? Can someone
Yes,
tell me?
sir. So you are writing EMP number, employee number 0010 as a null.
Okay. I'm making the department ID of employee number to null. Currently it's a A00. I know that. I'm making it to null. Let me execute this query first. 1. Okay. So let me select this data. Here, the work department has become null for the first employee with a 0010. Okay. Now I want to write a query. I want to select. See, I want employee number, last name of the employee, work department of the employee, comma, department name, which is a column of the department table. So from how many tables I'm selecting the data here? Is it from a single table or 2 tables?
2 tables.
From EMP, comma, DEPT. There is no common name here. That's why I'm not using a correlation names. Where A dot work department equal to B dot department number. Department number is a column of the department table, which is a primary key. Work department is a column of the child table, which is a foreign key. So, which is an inner join. We get only matched records. Yes or no? Okay. Let me execute this query. How many rows are there in the employee table? There are 42 rows available, and there are 14 rows available in the department table. 42 rows available in the employee table, 14 rows available in the department table. Just now I executed and I have seen the stats. But one of the employees having a work department as a null, yes or no? I made
Yes,
a, for the first employee, the work department as a null. Okay. But there is no nulls in the primary key of the parent table. No nulls. So primary key doesn't accept nulls. But I'm asking work department of the child table equal to work department number of the parent table. So out of 42 rows, we get only 40. 1 second. There's a mistake here. Okay. Select the employee number, last name, work department, for department name from EMP. Our department is where? Sorry, actually, I am not. I should not give this A dot B dot. Sorry for that. Yeah. Correlation is not given actually. Sorry for that. See here, out of 42 rows, I got only 41. There are 42 employees, but one employee is not having a department number. That's the reason that employee is not selected here, because this null is not matching to the primary key. Do you understand?
Yes, sir.
Yes, sir.
Okay. This is called an inner join. In an inner join, we get only matched records from both the tables. Matched records on this matching condition. Matched records on this matching condition. If any row is not matching to this criteria, that row will be discarded. It will not be selected into the output. Do you understand?
Yes, sir.
But my requirement is different here. I want to go, in case if the department is assigned to any employee, give the department details. Otherwise, at least give me the employee details. In case, see here, I am selecting 1, 2, 3 columns from the employee table and only 1 column from the department table. Yes or no?
Yes, sir.
So in case if the department is there for employee, give me department name. If it doesn't have a department number, if it is null, at least give me the department, at least give me the employee details. Give me department name as a null. That's called a left outer join. In an inner join, we get only matched records. In a left outer join, we get matched records as well as unmatched records from the left side table. Which is the left side table here? Out of these two tables, which is the left side table?
EMP.
Employee table is the left side table. And EBIT is the right side table. So now, if you want to get a left outer join, if you want to go with a left outer join, meaning is here, give me the matched records from both the tables and also unmatched records from the left side table. Unmatched records from the left side table. That means, in case if any of the employee is not assigned to any department, give me at least employee details for that employee. And give me nulls on the right side columns. Okay, for that employee. So department name as a null. Department name give as a null. Okay, that's the meaning of that. So let me execute it. Select how to write a left outer join. Select employee number, comma, last name, comma, work department, comma, department name from, okay, from EMP. Don't use a comma. Okay, left outer join, this is a keyword. Left side table, table name, left outer join, and do you understand? Left this table, left outer join, right table. Don't use a comma. Generally, for inner join, we give a employee table, comma, department table. But here, employee table, left outer join, department table. Instead of using a where condition, we have to use an on condition. On, then use a left outer join, right outer join, full outer join. So we have these many joins: inner join, left outer join, right outer join, then full outer join. So we have four types of join like this. This is an inner join, and left outer join. I'm showing it now. Okay. So for left outer join, okay, we have to for all these inner. If you use a left outer, right outer, full outer, you have to use on condition, not a where condition. On condition. On work department equal to number. Don't use a where condition. Use only, for example, you want to use apply one more condition. See, join condition must be given an on condition, but if you want to give other filter conditions like predicates, we call it as a predicates. Where okay, sex equal to F. I want only female employees. I want only female employees. In that case, we go with the where condition. But join condition must be given an on condition. But here, join condition and other filter conditions must be given with the where condition. But when it comes to the left outer, right outer, full outer clauses, so join condition must be an on condition. Other predicate must be given in a where condition. Guys, do you understand?
Yes, sir.
These are all rules. We need to understand the rules and we need to by heart the rules. Okay. So on work department equal to department number. I don't want to write a gender here. So let me execute it. Earlier, when I executed this query, we got only 41 rows because one of the employees having a department number as a null. But here we get all the 42 rows. But for 41 rows, we get a department name. For one row, we get department name as a null. Here, we see how many rows are selected. How many rows are selected?
42.
42.
That means we got all the left side rows. Matched rows and unmatched from the left side table. But in case if the left side row is not matching with the right side row, then we get a null on the right side column. Okay, we get a null on a right side column. This is called a left outer join. Left outer means we get a matched rows from both the tables and also unmatched rows from the left side table. Do you understand?
Yes, sir.
If you use okay EMP table right side and department table in the left side, now it is a right outer join. Right outer join. Result is same because I changed the tables from left to right. Now I used a right outer join. You understand? Yes, do you understand?
Yes, sir.
Let me extend this class up to 11 o'clock. Then I'll wind up this class. Okay. Is that okay with you?
Okay, sir.
Okay. So here I'm selecting left side columns as well as right side columns from left side table, left outer join, right side table. On. Don't give a where condition. Give a on condition. For example, I want only female employees. This I should not give as a on condition. This I need to give as a where condition. I got only 19 rows. Some records are filtered with this where condition. First, where condition is applied. Then the join is applied. That's why generally we give a where conditions first, then join condition next. 1 second. It's like this. One second. Sorry for that. We have to give on condition only first. I mean, use join left outer and right outer join. We need to use on condition first. So let's go to the right outer join. So we have a 40 rows, right? Have 42 rows in the left side table and 14 columns, 14 rows in the right side table. Yes or no?
Yes, sir.
42 rows in the left side table and 14 rows in the right side table. And one employee is not having a department number. So that means only 41 will be selected from the left side table. No. Because it's a right outer. It's a right outer. That means match records from both the tables. Okay. And unmatched records from the right side table. There are 14 departments. Out of 14 departments, only 8 departments are there in the employee table. 6 departments are not there in the employee table. Do you understand?
Yes,
Because
sir.
I know the scenario. I know the data. We have 42 rows in the left side table, 14 rows in the right side table. Out of that, 41 rows are having, 41 employees are having a department number. Total number of departments in the employee table are 8 only. 8 employees are working in only 8 departments. The employees are not working in other 6 departments. If you go for right outer join, we get the matched rows. So 41 rows are having a matching data, correct? And then how many are not matching in the right side table? 6 rows. So what is the total number? I want a matching data from both employee table and department table. And in case if the right side table is not matching with any left side row, I get those rows from the right side table. There are 6 departments which are not assigned to any employee. So let me execute this. How many we got?
47.
So see here.
47.
Yeah. See here. 1, 2, 3, 4, 5, and one more is there somewhere. Yeah, here. So all these 6 Hey, I'm sorry. I lost the power here. I connected from my hotspot. So are you able to hear me?
Yes. But
So
Yes, sir.
so many students are left.
I'm sharing my screen. So here I'm explaining about the right outer join. So we get the matched records from both the tables on a matching condition and unmatched records from the right side table. There are 41 rows matched from both the tables. Okay. And there are eight rows, 6 rows, I think, which are not matching to the right side table. Okay. 41 plus 6. Yeah, 41 plus 6. Totally 47. So do you understand the right outer join?
Yes, sir.
So let me execute a full outer join. That means match records from both the tables, match records from both the tables, and unmatched records from the left side table, and also unmatched records from the right side table. So how many records we have? 42 rows from the left side table, and then 14 rows from the right side table. So we get all these rows. So what is the total number? Sorry for that. Oh, 1 second. 42 rows are matching. 41 rows are matching records. One row is not matching from the left side, and one row, 6 rows are not matching from the right side. 41 rows are matching. One row is not matching in the left side table. 6 rows are not matching in the right side. Yes or no?
Yes, sir.
So now we get a matched rows from both the tables, unmatched rows from the left side table, and nulls on the right side columns for those unmatched rows, and unmatched rows from the right side table, and nulls on the left side columns on those right side rows. Let's see number of records. 48.
48.
Okay. So 41 plus 1 record, 41 are matching. 1 record from the left side table, which is not matching. 6 records from the right side table, which are not matching. So total it's a 48. Let's see here. Let's see here. Okay. We get a, if the matching unmatched data is coming from the right side table, we get a nulls on the left side. Table. Nulls on the left side. Similarly, if we get a unmatched data from the left side table, so we get nulls on the right side columns. So this is called a full outer join. Generally, we don't go for a full outer, right outer. We go for an inner join. Sometimes we go for a left outer join. That's a meaningful. I'll tell you the scenario. I need employees and also its corresponding department details. That's called inner join. That's called inner join. I need employee details and also its corresponding department details. It's meaningful. It's an inner join. The second requirement is I need employee details and also its corresponding department details. If the employee is not having a department, at least give me employee details. It's also meaningful. It's a left outer join. Think about this third requirement. I need employee details along with the department details of that employees and give me departments on which the employees are not available. Is it meaningful?
No, sir.
I want employee details and also corresponding department details. Okay. In case if any department is not there, give me department details. It's meaningless. So when generally we don't go for a right outer join. Mostly we get the unmatched records from the left side table, the child table, and try to follow this convention. Okay, so mostly we give a child table in the left side and parent table in the right side. That's a standard we follow. Child table in the left side and parent table in the right side. That's why we go with the left outer join most of the cases. Okay. So left outer join. Generally we go with the left outer join, either inner join or left outer join. But we never go with the right outer join. We never go with the full outer join. Those are meaningless requirements. Do you understand?
Yes, sir.
Yes, sir.
Okay. So let me, is it mandatory to write a where condition? There is a clause called inner join. Inner join. It's also there, but we never use it. I'll show you here. Instead of writing a inner join like with a where condition directly, with a from clause like this, table 1 comma table 2, we can also write it like this. From table 1 inner join table 2. Don't use a comma. And we need to use on condition. It's also possible. As per theory, we have an inner join clause. And also we can use the on condition. But generally we never give it like this. We always give a table 1 comma table 2 and where condition here. There are two ways to achieve the inner join. Table 1 comma table 2 and with where condition. Table 1 inner join table 2 on condition. So generally we go with the first method, table 1 comma table 2 and where condition. Okay, but this is also possible. Here, this is the inner join. Got 41 rows. Inner join. That means a matched records. So inner join has a two syntaxes, but left outer, right outer, full outer doesn't have a two syntaxes, only one syntax. Are you clear with this?
Yes.
The keyword inner join, if you use it, you have to use the on condition. But if you use a table 1 comma table 2, you have to use a where condition. On condition is required only when you use a join clause in the from clause. Inner join, left outer join, right outer join, full outer join. I didn't show you full outer, right? Did I show? Yeah, I have shown full outer. Sorry for that. Do you understand?
Yes, sir.
We can also use a self join. We can also use a self join. Instead of joining the second table, we join the same table. Do you understand the scenario? Do you understand the concept? Instead of joining another table, we join the same table.
Yes, sir.
Let me show you that. Sometimes we require, okay, joining the same table. I'll show you the concept here. So let me go to let's say self join. See this table. I have employee number, employee name, manager number. Employee number, employee name, manager number. I want output like this: employee number, employee name, manager number, and manager name. I want a manager name. Do you have a manager name column here?
No,
No.
sir.
But manager name is available in other row of the same table. See, for 001, the John, the manager number is 002. What is the employee name of the 002 employee?
Steve.
Steve.
So that's a manager name.
Steve.
For John, Steve is a manager. For Steve, Nelson is a manager.
Nelson.
Stephen also, the Nelson is manager. For Nelson, the Diana is manager. For Diana, Diana is the manager. Or else null. Is the boss, is the CEO. No bosses for her. So no manager for her. It's a null. But for a better data representation, I have taken a 005 here. Now I want a employee number, employee name, manager number, and manager name. So when you want the data to select one row, the matching data is available in the other row of the same table. You understand? To select one row, the matching data is available in the other row of the same table. In that case, we go for a self join. Do you understand?
Yes, sir.
Take another example. There is a bank account. So bank accounts table. I have account number, my account holder name, account balance, account issue date. But introducer account number. Who introduced this account? There is another column. Introducer account. But there is no introducer name in the table columns. Introducer account number is there. But I want a output like this. Account number, account holder name, introducer account, introducer name. Where is this introducer account number available? In the other row of the same table. Yes or no? Guys, please try to understand. For example, in our batch, some of the students are referred by the same batch students. So I use like this: student number, student name, okay, contact name, contact number, and who introduced, referred by another student number.
Yes, sir.
Another student number. So I have a table like this: student number, student name, referral student number, student number, student name, referral student number. But I want output like this: student number, student name, referral student name, referral student number, and referral student name in the output. Do you understand? While selecting one row, the matching data is available in the other row of the same table. So in that case, we go with
Yes, sir.
the self join. Self join. See here. Taking the EMP as an employee table, taking A as an employee table, and B as a manager table. Assume it's like a manager table. This is an employee table, and assume this is a manager table. But both are employee tables only. Both are employee tables only. But assume this is an employee table, and this is a manager table. Let's write a query like this. See here. Select A dot employee number from here, and A dot employee name from here. Okay, from here. And A dot employee manager, that is from here. And a B dot employee name, that is from here. Where this is matched to this. So from EMPA and EMPB, where A dot employee manager equal to B dot employee number. Yes or no?
Yes.
Yes, sir.
This is called a self join. Treated this as an employee table, this as a manager table. I'm joining these two tables to get a manager name. So B dot employee name as manager name. Select employee number, employee name, employee manager, and manager name. So manager name is coming from second table. So for this employee, I'm joining, okay, this with this one. For this row, I'm joining this one with this one. For this also, we're joining this one with this one. For this one, we're joining here. Do you understand?
Yes, sir.
Okay. Fine. So in today's class, we have seen about unions, joins. In unions, we have a union, unional, union, unional, intersect, except. Intersect, except. In the joins, we have seen inner join, left outer join, right outer join, full outer join. But mostly we go with the inner join or left outer join, where we give a child table in the left side and a parent table in the right side. It's not a rule, it's a recommendation. Okay, if we do not give a where condition, join condition in a joins, what we get? If I have 10 rows in the left side table and 5 rows in the right side table, if I don't give a where condition in an inner join, how many rows we get it?
15.
15.
50, 50. Cartesian product, not 15. 50. So Cartesian product means the left side row is matched to every row of the right side if you do not give a where condition. Okay, that's called a Cartesian product. We have already seen that.
Sir, in the
17,800. Yes, please.
sir, in the above query, we have not defined A and B. Employee A has as A or employee B as B,
No, actually, as
and
is
we are
not
using
required.
A
Yeah,
dot.
I understand. I understand. We can use in a tables. We can use either as, or we can simply give a space. But on a columns, we have to give a as. In the table name, when you're giving an alias name for a table, you can either give it as A or simply A. No problem at all. Both are correct.
Okay, okay.
Good question, but this is the answer. So unions, joins, both are covered. Okay. Do you have any questions here?
No, sir.
Inner join, left outer join, right outer join, full outer join, self join.
No, sir.
Okay. Fine. Yeah, I'll wind up the class now because I need to catch an interview. So please plan yourself to come here on 28th of this month. From there, it'll be offline classes, and I'll give you more subject knowledge in a classroom training. That's more interesting. Okay,
Okay, sir.
where I can write on a board, where I can show I can see you, I can able to understand whether you're understanding the subject or not. Okay, you can practice it here, where you can find lab coordinators. But see, some people put a lot of effort in the initial days, maybe first 1 week or 10 days, and then their interest level will be going down. Very few people are putting effort consistently, and some people are increasing their strength in the end of the training. That's really, really good. So they're putting up good efforts throughout the course, but they're increasing their strength in the end of the training. Say, for example, I'm going for a competition, maybe any athletic competitions, or maybe running race, or maybe long jumps, whatever it is. So I have 1 year. So I practice a lot throughout the year, but last 1 month, my practice level should be increased. Yes or no? But very few people are doing like that. So I want you to be like that. It's your life. It's your life. However you want to mold it, it'll be molded like that. Okay, do hard work and get the knowledge for a survival level and go and join. Even though you are identified as a fake, no doubt, all of you, if you join somewhere, okay, you will be identified as a fake. No doubt in that. You cannot, okay, show as a, you are a genuine candidate. Impossible. But only thing is, okay, at least you can show up. Yes, I know the subject very well. Give me a chance. Okay, I can prove myself. If you create such a confidence, don't ask like this. If you ask like this, that means you're saying you're a fake candidate. So you should never ask like this. But you show all this with your actions. So then they give you a chance. Definitely they'll give a chance. They'll help you. Okay. Thank you very much. Thank you for joining. That's all for
Thank
today.
you, sir.
Thank you,
Okay,
sir.
sir.
Thank you, sir.